Good morning, and thank you for joining today's webinar from SPEC Innovations, Functional Modeling 101. My name is Taylor Duffy, and I'll be the moderator for today's webinar. First, I'd like to go over some housekeeping. Next slide, please. During the presentation, feel free to send us questions and we'll get them answered in the Q&A part of the webinar. You can also interact with us on LinkedIn through the Innoslate users group or through Twitter using the handle @SPEC Innovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Next slide, please. Now, I would like to introduce you to our presenter, John Schatz. John Schatz currently serves as the Vice President of SPEC Innovations. He has more than 30 years of postgraduate experience as a program manager, director of systems engineering, and various systems engineering and technical roles. He directly supports business development and technical performance with the U.S. Navy and other customers. Mr. Schatz designs tailored digital engineering environments to support DoD research and development and test and evaluation initiatives. He received his bachelor's in mechanical and aerospace engineering from Cornell University in 1991 and master's in electrical engineering from Virginia Polytechnic Institute in 1996. Feel free to send him any questions through the LinkedIn users group or email to marketing@specinnovations.com. And now I'll hand over the controls to John and we'll get started.
Great, thank you, Taylor. So I'm going to go through and talk about some functional modeling aspects within Innoslate. We'll touch on action diagrams. We'll have some demos on that, and then we'll talk about how we simulate those action diagrams. And we'll follow up with an additional model and additional demo, and then we'll go into Q&A. So to start out, action diagrams are used within Innoslate to express functionality and behavior. These action diagrams can also be transformed into other views within Innoslate. I'll point out how that can happen, but you can also get sequence diagrams out of this information. You can get activity diagrams, potentially timeline diagrams, depending on what you're trying to accomplish. But they are rendered views of the data that you put in the database, and hence can be transformed into a lot of different things. So typically we use them for modeling scenarios, for modeling operational threads or business processes. The key here is that they have both sequence from left to right information, and they show data flows. So what you're seeing here in the green and the gray, those are data elements that are getting passed in. We can also show allocations. I'll point that out on the next slide, and resources. Resources are going to be the purple polygons. And we can execute these models in both the discrete event and Monte Carlo simulator that's part of Innoslate. So when we build action diagrams, we have a palette. It's contained in the sidebar on the left. That contains a bunch of elements that we can drag and drop right onto our screen. So I'm just going to go through a few of these elements. You can see here, this is a parallel construct. It's got more than one branch. We are able to add branches. The initial drop will put 2 branches on there. The parallelogram, if it's gray, it is a input output that is a trigger. That means it's required for the action that it goes into to be received before that action executes. If it's gray, it's optional and the action can execute without receiving it. Branch assets, these are allocations to assets. So for example, if I put this branch asset on a branch, I would be dragging from here, drag it over to here. Any action I put on that branch will receive that through a performed by relationship. So it's a quick way to get a lot of your actions allocated to assets. What we're seeing down here at the bottom is an OR construct. We will talk a little bit more about that in the first model demo. Down here at the bottom, you can see this is a resource that we've drug on. And here we have an action with the word decomposed at the bottom. Whenever we see a decomposed, what that means is that there's child actions that are sitting underneath that action. So in this case, if we were to click on that bar down here at the bottom that says decomposed, it would take us into the lower level diagram. This is important because when we execute a model, what happens is only the leaf level elements in the decomposition tree will actually execute. So whatever you have inside this decomposition diagram, that's what's going to execute, not the parent. So keep that in mind. Okay, when we're adding these different entities to the diagrams, we have a sidebar that shows information about them. So you'll have a couple tabs across the top here. One will be the metadata tab that will show information like the class of the entity that was put in. And in this case, since an action is selected, it would show action under the metadata tab. It would also show things like the unique identifiers for that, the name of it. The attributes tab, it shows different information depending on the type of entity you have. So here we have an action entity. It contains information like duration and start. And then we have a relationship tab. And the relationship tab shows all the relationships to it. In this case, it would certainly have a decomposes relationship with the parent, but it may have others as well. And you can see those. There's ones that are pinned, which are set by the organization. There's ones that are active. Those are ones that have a target for that relationship. And then there's the all option. The all option allows you to pick anything. Ones that either have targets or ones that do not have targets, and you can add to those. Here we're looking at a IO that was selected. You can see that it's selected because it has the blue box around the outside. And you can see here it's got some different attributes than we saw in the action. So in this case, we've got a size and a units attribute. Here we've selected up here on the right, we've selected a resource, and you can see it's got other fields like initial amount, minimum amount, maximum amount. So depending on what you select, you'll get different fields. Okay, so now I'm going to go ahead and I'm going to start creating a model. The first one that we're going to create is going to demonstrate how to put things from the palette into the diagram, and how to control the loops. And in this case, I'm going to do some simple loop control, probabilistic in this case, and then we will expand upon that in the next demo. So I'm going to go into Innoslate, and if I'm logged out, I'm going to log in. And where I'm going to go here first is the diagrams tab. So you can see I've already selected the diagrams tab. When you come right in after logging on, you get the dashboard. Then I'm going to go to diagrams, and I'm going to go over and create a diagram. So if I look at the drop down, I've got two options. I can either create it from an existing entity that's already out there. Maybe I've already got something that's in a decomposition structure and I want to flush that out further, or I want to organize the actions that are already in there. In that case, I can pick the existing entity and go do something with it. By default, it'll just create a diagram. So a new one. So in this case, I'm going to go click on the create diagram. It's going to go to the default. I want to create an action diagram in this case. So in this case, I'm going to model running around a track. So I'm going to call this one running loop. I'm going to give it a number RL. And what that'll be useful for is when the internal parts are numbered, it'll put that as a prefix. So I'm going to go ahead. I've got my model. Right now it doesn't have anything in it. I'm going to start by dragging some things in. So we're going to do arrive at the track. Arrive at the track. And we're going to say that takes 5 minutes to do. So we're going to try and model what we can do on our lunch break. Then I'm going to go ahead and I'm going to put in an OR block. I'm going to say, do I want to do warm up or not? We're going to assume that that's dependent on how much time I have for that given day. So we're going to put that in as a question mark. It's going to be either yes or no. We're going to go ahead and we're going to set the probability of doing it to 80%. So I'm going to go in here to script. I'm going to select probability. I'm going to say the yes branch is 80 and the no branch is 20. You do have to set both the branches. They do not auto set. So if I put 80 in the top and I don't set the bottom, it's going to not pick 20 automatically. You have to put that in. So I've set those probabilities. Then I'm going to go ahead. Let's drag over the warm up. Oh, before we do that, I'm going to set this to 0 minutes here. I'm going to say that's a decision that's made instantaneously. Then I'm going to go ahead and we're going to say warm up for run. And we'll say that takes 5 minutes. So I'm going here setting the times. And then after that, we're going to go ahead and we're going to do a loop. I drag a loop onto here. I'm going to say the loop itself doesn't take any time. And I'm going to go ahead and call the loop running loop. Then we'll go ahead and we'll put the actual running onto the diagram. So in this case, I'm going to run 400 meters lap, 400 meter lap on the track. And we'll say I'm going at a brisk pace, but not too fast. We'll say it takes 2.5 minutes. And then after I'm done, I'm going to depart the track. We'll say that takes 5 minutes. And then I'm going to go ahead and save my model. Okay, so before we go ahead and do anything else with the model, we're going to go ahead and do another slide or two. And then I'll come back to that. So Innoslate has 2 different simulators in it, and these are used to verify your model logic or determine values that potentially you could use those values in a requirement specification or for some other reason. But we have a discrete event simulator. The discrete event simulator is nice for doing debug. It'll allow you to step through things or just to do single runs. It doesn't take long to run, and you can make sure that the logic of your model follows what you want it to follow. A lot of times we see on the first time we put the things in the model, we may find out things are not right. For example, if I hadn't caught that duration on the warm up or block as being 1 hour and set it to 0, I would run this model and I'd find out that it's an hour too long, and that would give me a hint that I need to go back and adjust something. Or I may find out that I'm waiting for something and it never arrives. So that's a good way to use the discrete event simulators to do a lot of debug and to just make sure you can get through one run. The Monte Carlo simulator is very useful when you have variability in the model. We have some variability in this model, so we'll see depending on the number of loops that will run, or whether the OR block was a yes or a no, we'll see different durations. So we'll be able to tell some things from the Monte Carlo simulator as well. So I'm going to go ahead, I'm going to go back to my model, and I am going to go ahead and I'm going to run this model first in the discrete event simulator. So as a default, you're going to get this status and these total time and cost windows. I'm going to go ahead and add some other windows here. I'm going to add the 3D trace. This will show me where I'm executing in the model. And I'm going to go ahead and I'm going to add the a Gantt chart down here at the bottom. And now I'm going to go ahead and run the model. So in this case, I've not set it to automatic, so it's going to prompt me anytime there's something that it wants to do. So in this case, I said run 3 loops, and it took me 17 minutes to get through this. The running exercise, so you can see here, I did 1 loop, 2 loops, 3 loops. Okay, now I'm going to go back in. I'm going to reset it. I'm going to let it not prompt on script. So I'm going to set decisions to automate with no script. I'm going to save that. I'm going to run it again a few times in the discrete event simulator. So you can see here, we went through all the blocks. Doesn't look like we ran a whole lot. Here we did 1, 2 loops. Let's try it again. Okay, it's going through the loops. Once again, it did 2. Let's try it one more time. And it's still stuck on 2 here, but it skipped the warm up that time. So let me go look at the probabilities I have set in that loop. It seems like it's not quite what I expected. I was expecting 80%. I didn't set it. So what happens when you don't set it is it goes to 50-50. So 2's probably reasonable for getting out of there. I'm going to go ahead and set it to 80 and 20. And we're going to go back and rerun that. Let me save first. Back in. Rerun it. And let's see what happens this time. So we were getting about 20 minutes before. This time we got less. Okay, well, that's a surprise. Let's try it again. Okay, we got some more laps this time. So this time we got 4 laps. So, but we skipped the warm up. So we're still at 20 minutes. Let's try it one more time here. Okay, that time we came up with a lot of laps and we did do the warm up. You can see that this box was not gray at the end. It's gray when it gets skipped. It's blue when it's executed. And you can see I did 1, 2, 3, 4, 5, 6, 7, 8 laps. So I ran 2 miles. Okay, let's go look at this in the Monte Carlo simulator, and then we'll be able to see how it looks there. So I'm going to go ahead and I'm going to run it 100 times. It defaults to 100. You can change that number. Usually I like to run at least 1,000 when I'm doing it, something other than a demo. So you can see here I've got a spike here at the start. This is where most of in these first 3, most of my runs fall between less than 16 and 2/3 minutes and, sorry, less than that. And also between that and 33. So very rarely am I over 33. Got 8 runs out of 100. So 8% of them did come between 33 and 42. Then I had a few outliers that became a little higher. So we're going to go ahead. We're going to build another type of model now, and we'll look at that. This is one where we're going to do a different type of triggering on the loop. So in this case, for the loop, you have a couple different options. You can do a script, you can do a probability, you can set it to a number of iterations, or you can do a loop resource. Let's go ahead and I'm just going to set it to a number of iterations here, and we'll see what that does. I'm going to set it to 8. So I'm going to say every time it's going to do 8. And we'll see when we run it this time. Go ahead and run in the discrete event simulator. It should run exactly 8 loops. You can see there's my 8 loops. So that's a case where I didn't put it to chance. I said, this is how many I'm going to run. And the only thing that went to chance was whether or not to do warm up. In this case, it came up no. So that box here is gray. Okay, now we're going to go look at a different example. We're going to go back to diagrams. I'm going to create a new diagram. This diagram, I'm going to try and simulate mail processing within an organization. So this is going back to the old days when we actually had real mail and people would distribute it from a mailroom. And we'll number this MP for mail processing. And I'm going to go ahead and I'm going to start by putting a parallel structure on here. And I'm going to add an actor to each of those branches. So these are assets that are getting applied to the branches. And the first one's going to be the mail carrier. And I'm going to add one to the bottom for the office worker. And what I'm going to have is I'm going to have the mail carrier deliver the mail. And they're going to output mail. So they're going to bring the mail. What I'm doing is I'm grabbing this green circle here and I'm dragging it toward the mail input output. And then I'm going to have the office worker receive the mail and place the mail in their inbox. And I'm going to make this 1 minute duration for both of those. Got to do it on the top one. I'm going to go back and do that. And this mail is going to be a trigger for placing in the mailbox. So I'm going to go down here. When I float over top, I get an optional or trigger. If I set the optional, it'll be gray. If I set the trigger, it will stay green. Green indicates that it is being used and that action down below in this case, the MP2 place mail in box, that action cannot execute until after the mail has been received. So it's waiting on that IO before it's going to run. Now what I'm going to do is once I have my mail in the box, I'm going to want to process it. So I'm going to create a processing loop here. So this processing loop, the loop in and of itself isn't going to take any time. It's going to be the actions that are within the loop that take time. I'm going to set that to 0 minutes. I'm going to call this process mail. And I'm going to go ahead and put an action on there, which is review letter. And let's say that every letter takes a different amount of time. So in this case, I'm going to set a distribution instead of the same value every time. So I'm going to pick a triangular distribution in this case. I'm going to say it's going to vary between 1 and 10 minutes. And more often than not, it's going to be at 2 minutes. So I'm going to set the peak of the triangle at 2. And I got to put the units on there. So I'll pick minutes. That's going to be our review letter. Now, the key thing we want to do here is we want to put a control on here for that mail, so it knows how many times to go. We could just let it be a probability and assume that we get a certain number of occurrences, and we could control that as a probability in the loop. In this case, I want to illustrate using resources to control loops. So I'm going to go ahead and have a resource out here called mail in inbox. And that's going to be generated by place mail in inbox. And it's going to be consumed by review letter. So there's, you see when I float over top here, there's two options. There's consumes and seizes. So the difference is that consumes takes the mail from the mail and inbox resource, and once it's taken, it is used. It never goes back in the inbox. If I use seizes, when the action is done completing, it will go back to that resource. So that may be a case where you had a number of items and you wanted them to be used for a certain period of time and then put back. That would be when you would use the seizes instead of consumes. So I want consumes. So I'm going to go ahead and I'm going to save this before I do anything else. Come back in. So I'm going to look at the loop here. I'm going to look at how it's exited. So I got the 4 options. I can do a script, which is a custom script that I write. I can do the loop probability. I can do the number of iterations. We've looked at both of those. In this case, I'm going to do a loop resource. So with loop resource, you're going to pick a resource. In this case, it's going to be mail and inbox, and then you're going to set conditions for that resource. So in this case, when I have mail and inbox greater than 0, I want to continue processing the mail. Once it hits 0, then I want to go down the exit branch down here at the bottom. So I'm going to go ahead and submit that. Now, the one thing I haven't done yet is I haven't set the amount of resources and the consumption of the resources. So typically, I would want to be able to do that by clicking on the action, looking at the active relationships, and then in this case, mail and inbox is here under produces, and there's what's called a relationship attribute. And that field, I should be able to type that in here. There's currently a known bug with doing that. Deals with the focus within the browser on the action diagram. So sometimes this works, sometimes it doesn't. That's getting fixed. But the way for it to work, you should be able to go out and to the right and lower, click in the white, and then save it. That's not a good workaround. And I'll show you what the good workaround is. Let's just see if it took that time. I'm going to go back here under active, pull them up, mail and inbox. Yeah, there's no value. So it didn't work. It doesn't work all the time. So the workaround we have at the moment, and this should only be another month or 2 before the fixes roll in, is to go and open any of the entities in entity view and then set the values there. So here, when I open the resource, you can see it's produced by mail and place mail and inbox, consumed by reviewed letter. So if I go set the relationship attributes here, I'm going to say, I'm going to put 15 in there. to start out, 15. And then I'm going to go up here under review letter. I'm going to say I'm going to review one time. And then I'm going to save those. Now, when I come back in here, I should see them under the relationships. Mail and inbox got 15. Review letter, consuming 1. Okay. So that's the short-term workaround. So if you're using resources, just be cognizant that it's not saving as it's supposed to on the action diagram sidebar. Now I'm going to go ahead and I'm going to simulate this. And I'm going to use the discrete event simulator first. This action trace 3D up here at the top that I saved, it looks a little big. I'm going to go ahead and I'm squeezing it with the using my my mouse. And I'm also going to put in here a chart for the resources. I'm going to look at the resources over time. And I've only got one resource, mail and inbox. I'm going to put that in there. And we're going to look at what happens to that. We'll see a chart of that. So let's go ahead and run this. Okay, there it goes. So you can see we started out here in the Gantt chart. The mail was delivered. You see this yellow vertical bar here. That means that it's in a wait state. So the place mail and inbox, it can't execute until after it's waited, and it has to wait until the deliver mail happens, which takes 1 minute, and then it receives that action. So that's what the yellow stands for. And then I go into my processing loop. I have 0 duration on the processing loop, and I have some time I've allocated in that triangular distribution to the reviewing of the mail. So you can see here, this one was 4.2 minutes. This one was 8.86. This one was 7.14. And some of these down here are shorter. So we've got different varying lengths of time I take to go through the mail. And then you see over here on the resource chart, started out at 0, and 15 were added when I got to that box, and then it slowly works off over time until I get down here to 0. And then I look at it one more time when I'm coming through that loop for the final pass, and it says we're out of mail. Let's go ahead and exit. So that's what's going on. In this case, it took 1.15 hours. Now let's go back and we'll run this in the Monte Carlo simulator, and we'll see what happens when we run it a lot. So here's 100 runs. We're going through running it 100 times right now. And you can see I've got a time distribution. Kind of looks like somewhat like a bell curve. And that variation is being driven by that triangular distribution and where things fell within that. And I would imagine the more runs I do, the more it's going to drive towards some type of a bell curve, I think. Although it was a triangular distribution, but there were a lot of fixed duration actions within that diagram. Okay, so that's the demo. You can see also over here on the left, you do have a mean time was running for 1.12 hours, and the standard deviation is 7 minutes. So that's useful information. And I'm going to go ahead and go back to the slides. So what we demonstrated there was the discrete event simulator, the Monte Carlo simulator. We went through a number of options for loop control. We went through just the number of iterations. We went through probabilistic control for the loops, and we showed how you can use resources to control the loops. So that's all I have for the demos. There's more information out there online. We have different training opportunities. There are other online webinars, video tutorials. We do provide virtual and on-site team training. And you can contact the sales at innoslate.com, and they'll help you with trying to get matched up with training that's appropriate for what you want. We do a lot of customization on the training, and we have a number of out-of-the-box courses that we can also offer. So I'm going to go ahead and turn this back over to Taylor.
Thanks, John. If you're interested in having our team help you get started with functional modeling for your project or system, contact our sales team to get you started. You can reach them by email at sales@innoslate.com or through our website, specinnovations.com/contact-us. Next slide. We've received several questions already. If you haven't done so, please send your questions through the panel on the right. We will answer as many questions as we can before our time is up. The first is, how can we change the simulator background color from black to white?
Yeah, if you were observing closely in the slides, we did have a white background here on the model when we had it in the simulator, and that's a pretty simple thing to change. So let me just go into one of the simulators here. Let me go into the discrete event simulator. There's a settings option down here, and we have a dark and we have a light mode for display. So that would be where you would save that setting, and that will allow you to have a background that may be more appropriate for putting in the slides that are going to get printed out, because there's less darkness in the background.
Great. Next question, how do I add cost to the model?
Yeah, so if you noticed on the different simulators, we have a cost field here, and that's something that didn't show up on any of them because we didn't have it in there. So let's just take a quick look here at the model of processing the mail. So in this case, I'm going to, for simplicity, I'm going to go ahead and I'm going to go into the review letter one, which has the most variability. And the way we would add cost is we would put a cost element into each of these different items here, and that's done through the incurs relationship. There we go, incurs cost. So I would get down here and I would add a new cost element. In this case, I'm just going to call it new cost. I'm going to say it's an amount of let's see, we'll say it's $100, and we'll say it's a per hour rate. Maybe that's the cost of the employee. And I'm going to go ahead and I'm going to save that. So now I've got new cost in here. I'm going to go ahead and add it for this one too. This one's also got employee time associated with it. So if we go under incurs, I do have all selected. So we would go and we would add. I'm not seeing it because I haven't saved it yet. Until you save the model, persist the model, then the elements don't show up in the list. So if I go over here under relationships, go to all, should be able to see that now. There's new cost. So I just added to that one as well. I'm not going to worry about the mail carrier. We're going to assume that they are paid for under a different pot of money. So now I've put cost elements on here and on here, and they're tied to the duration of those tasks. $100 an hour for the tasks. Let's go back into the discrete event simulator and run it again. So let's see what happens this time. So now you can see it took 1.21 hours. It cost $119 to do the mail that day. The reason it didn't cost $121 is because the mail carrier's time is in there as well. That's part of the overall thread, but it's not calculated in the cost. And once again, we can run that in the Monte Carlo and see what it looks like there. So we should see a distribution on this in the Monte Carlo. You'll notice that the background on the Monte Carlo has to be set separately from the discrete event simulator, so it's still in the dark mode. So you can see I've got a mean cost of $106 with a standard distribution of 12, and here's my cost chart, and that mirrors very closely my time chart here. If I run it one more time, let's see what it comes up to. If I run it again, it'll be a little different. Probably not a whole lot. So in this case, the distribution was slightly different, and the cost is different. That's one of the reasons that I tend to like to run at least 1,000 runs, possibly more, depending on the situation, because it will allow me to get figures that are more consistent. 100 runs typically does not give me the consistency that I want when I'm trying to make real decisions on it. Any other questions?
Yes. Next question. Can If we can, how do you use these diagrams as a template for more to use?
Could you repeat that one more time?
Yeah. Can/how do you use your diagrams as a template to use in the future? Like, can you clone
So
them?
yeah, so typically what I would do if I wanted to have them as a template, I would go ahead and I would export them as .ini files, and the way to do that would be to run a report. Let's see. I would go and filter in database view. I don't think I can do it from here. Let's just check. I can do it from here. So I would do a diagram zip output.ino, and I would give it a name. So in this case, we'll call it mail processing. And then I'm going to export it. And when I do that export, I've got it that I can re-import. So now let's just say I want to re-import that again. I'm going to go here to import analyzer. I'm going to go pick the .ino, and I'm going to drag this into here or select it. So in this case, it's in my download folder. And I think it did not do it because I did not, I re-imported into the same one. But let's look. Yeah, I didn't do quite what I wanted to there. You could do that and bring it into multiple projects separately. Typically, when I do a project level import, and what I would probably center on would be to do this entire thing as a project, and then uh, bring the project back in. Let me just check on the import analyzer again. I think the key here is you want to get different global IDs, but I didn't pick the global IDs in the let's do reassign globals. I think that will fix it. Let's go bring it in again. So now I've got two copies of this sitting out here. So if I go into diagrams, here's my one, and here's my new one here on the left. So now I can go ahead and I can modify these. Let's say I wanted to add another action up here on deliver mail. Maybe go back to mailroom, and maybe that takes 10 minutes. And then the other thing I might want to do is I might want to do a renumber on these, because let me go ahead and save it first. And I might do an auto number. Maybe I want to call this MP2. If you're doing the auto number from here, you need to put a dot afterwards. Otherwise, it will not put a dot. You need to do that for it. I'm going to go ahead and run this. Now I've got new numbers on those. And when I go back to the database view, I can now distinguish between my new model and my old model, which is down here. So that would be the way I would use it as a template. So the key is export it as a .ini file on import analyzer. When you go into the .ini import, make sure you hit reassign globals, and that way it won't just overwrite what was already there. It will create a new set. Any other questions?
Yep. Just follow up for that one. So we should use the .ino file and use Git to configuration manage them for the whole department. Is that correct?
Yeah, that would be my recommendation. Would be to use the .ino files. If you use the .csv export option, there are benefits to doing that in certain cases, in that you will be able to potentially modify the relationship targets if you want to go down that path. But what you will lose is the diagram positioning. The XML files, pretty identical. I think they're identical at this point to the .ini. It's just a different format for it. So you can either use .ino or XML. Typically, we use the .ino. The one nice thing about .ino is that it's a zip file. So like any zip file, you can go and you can rename it from .ino to .zip, and then you can go through the directories and pull out images if you wanted to that are embedded in there in the zip file structure.
Right? How do you add new units?
Units are for the cost. For cost, it's just whatever you put in there. So if you put in dollars or cents or pounds, it's whatever you typed in there. So you need to make sure you have consistency for the cost elements. For the time units, I think you're limited to the time units that are in the system already. So let's see what those are. Um, Seconds, minutes, hours, days, weeks, months, or years. So if you wanted to go to something that is other than those, you would need to pick. You would need to do some type of conversion before putting those in. So, for example, you would need to let's just say you wanted to go to milliseconds. You would need to enter the duration in seconds and then divide your number by whatever you need to divide by 100,000, I think it was for that, or a million. So you're going to have to convert to one of these units for the time units. But for cost and the other things that are not in the action diagrams, you can put in your own units. You just need to be consistent in how you do that.
Great. Are you considering a post processor to create pseudocode for a design document or to be imported into an IDE?
Can you elaborate on that a little more? Whoever wrote that.
Yeah, we'll go to the next one. If you could elaborate, please. Remind us how to trace a requirement, please.
Yeah, sure. So the actions, they would have they would need to be traced from statement. So you would basically you go select your action, and then you would go and you would pick a related existing entity down here under traced from, and you could tie it to the requirement that way. In this case, I don't have any requirements in the database, but if I were to go create one that's a standalone one, be sitting out here called new requirement. I could tie it to that deliver mail. Maybe I also tie it to this one down here. I would need to save first if I'm going to do that, because otherwise it's not in the database until it's saved. I could then go and tie this one down here to an existing entity, in this case, the new requirement one that I had already picked. And those requirements typically would be held in a document, a requirements document. We talked some about the requirements documents last month in the webinar. And likewise, you could use the inverse relationship of that in the requirements document and go select your actions. So it would be traced. Here we're using new requirements traced from, but if I go to that new requirement itself, it's going to have a traced to relationship. So it's the inverse relationship that you're seeing when you view it from the perspective of the requirement.
Great, thanks. That last question can be disregarded, and we have one more question. What does a sync block do?
Yeah, so there's a sync block up here, and the sync blocks are useful when you have a number of different users doing things, and only one of them has to finish. So in this case, if I had a diagram that looked like this, maybe I had an action here, and I had an action here, and they had different durations that were unknown up front, and maybe vary with the um, run. Maybe they're distributions or something. What the sync block does is it says it's the kind of the opposite of a parallel structure. In that, a parallel structure, for me to get to this point here at the end of it, each of these branches must complete. So only when all of the branches are complete can I move on from the parallel structure? So a lot of times when you're doing debug, you'll see yourself get locked up on those parallel structures because maybe 3 out of the 4 branches finish, and the other one's locked up because it's waiting for something it will never get. So, so with a parallel structure, everything has to finish. With a sync block, only one of these has to finish. So maybe I have both of these actions waiting for different triggers to occur before they can execute, or they're different durations. As long as one of these finishes, I can execute the sync block and then move on. The other one may never finish, or it can finish later. It doesn't matter. It just needs one of these to finish in order for that sync block to execute and for me to continue on with the simulation.
Great, thank you. That looks like all the questions we have for today. If you could go back to the slides, please. We would like to thank you again for joining us today. As a reminder, we'll be following up with you very soon to send you a link to the recording and the presentation slide deck. Could you go to the next webinar slide, please? We hope you can join us for our next webinar, LaTeX and Innoslate, Adding Math to System Models, on Tuesday, July 23rd at 11 a.m. Eastern. Dr. Stephen Dam will share all the ways Innoslate is truly a mathematician using features such as computable attributes, parametric diagrams, and more. Your link to register will be in the email that is coming soon to your mailbox with the slides and recording. Next slide, please. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Have a wonderful day, and we hope to see you at our next webinar.